We'll just give folks another minute or two to join in before we kick this off here. So thanks so much for your patience and thanks for joining us today. All right, well, good morning, everybody, and thank you all so much for joining us for the last currently scheduled InDEEP training session that we'll be hosting today. The purpose of this particular call is to go through the technology performance level assessment, which is a primary part of what we are looking for as a part of the InDEEP prize. So with that, I will just walk you through the agenda really quickly. So if you could go to the next slide.
There we go.
Awesome. All right, we'll just start with a brief introduction to the prize. I'm sure many of you are already familiar with the prize itself if you're attending this training webinar, so we won't spend much time on that. And then we'll spend the majority of the discussion today talking about TPL in general, the TPL methodology that's expected for you to use as a part of this prize, and some of the things that you need to keep in mind when you're incorporating that during your concept development. Next slide. Right. So as I mentioned, this is a part of the Innovating Distributed Embedded Energy Prize, or InDEEP. The total cash prize pool that competitors can earn from is $2.3 million. And this is a 3-phase prize that is scheduled to run over the next 2 years. And our intention with this is really to incentivize progress in early stage research as it is related to distributed embedded energy conversion, and help us and help you to really solve some of the technical challenges that could be related both to your technology, whether or not it's within wave energy, and learn some lessons that could be applied to wave energy overall. So with that, we're really going to talk about specifically today how some of the challenges that we are trying to learn from, you can incorporate some of these specific methodologies to improve your concept design and help us to understand what are some of the biggest challenges that you've all run into in trying to improve your concept and apply it to wave. And next slide. All right. And then if you are new to the prize in general, since we aren't going into all of the specific prize details, I'd encourage you to watch the recording of the webinar that we held on April 12th. That is located in the webinars tab of the HeroX platform. So if you just click on that, it's all readily available. There's slides that are accessible there as well, and it'll just give you a brief introduction as to what we're looking for as a part of this prize. Participation in this webinar, and I mentioned this on all of the training webinars that we've done, does contribute to your final leaderboard score. If you are not signed up yet for the leaderboard, though, we are not able to track your points. So I would strongly encourage you to sign up as a part of that. It is just a basic introduction of your name, a confirmation of your eligibility to compete in the prize, and your team name. There is no required concept submission as a part of this, but I'm not able to track your points and give you points for participating today unless you sign up for the webinar. And so I'll put, if it hasn't already been put in the chat here, a link to that page. So if you're not already signed up, please do sign up today so that we can make sure that we can track your participation and give you points for engaging with us. And that, generally speaking, is one of the things that is really critical for us to understand how we can better help you, and how we can understand how to improve some of these, some of the programming that we have offered as well going forward. And with that, I think I will hand it over to you, Jakob, to introduce TPL.
Thank you very much, Jenny. So what I'd like to do is to talk a little bit about the motivation and the background where this technology performance level methodology came from. And I'm borrowing slides here from a presentation I gave actually, what is that? 11 years ago. And so the fundamental observations in different form, but fundamentally they do still hold. There has been a lot of progress, a lot of developments and adjustments in wave energy, but some fundamental statements still hold, and these are summarized here in terms of the key challenges. So there's still a diversity in terms of technologies, and we don't have a conversion yet. We have seen conversion type changes, but I wouldn't say we have a conversion. And the projected cost of energy has come down, is still projected to be reasonably high. And technology development is and was expensive in terms of 100 million or more to get to TRL 7. It clearly has high risk in terms of the large and detailed infrastructure that's being tested and developed, and the commercial pressures under doing so. It's been slow, but not slow due to slowness of the players. It's simply a long-term process. And it has, in many cases, been rigid in the sense that technologies have not necessarily adapted to the learnings that the development teams have delivered due to, for example, IP constraints. And I just want to give a few prominent examples for this. So at the time, and again, this is quite a few years old, but the principal observations still hold. OPT at the time had already spent 126 million. So it's just a publicly available example of money that's been spent in a given company without valuation of if this is too high or too low. It just says, okay, this business is not cheap to conduct. In terms of high risk, maybe Aquamarine might be an example of a large demonstrator that unfortunately failed not on system level challenges, but encountered component challenges, and that made it very challenging for the device and the company to deal with at the time. So it's high risk, component failure leading to system shutdown. And in terms of time demand, I believe that Pelamis was a good, complete technology development activity, a statement which is independent of notions about the technology. Purely, the activity, I think, has been comprehensive and has delivered progress on empirical, theoretical modeling, as well as decision-making tools progress. And it took quite a long time, kind of roughly 15 years. And WavePop, the company I used to work for a good while ago, has been, in my view, an example of rigidity, in the sense that the company was confined to an IP playing field, even though it would have been advantageous to be more flexible. And that's also a statement not of this company, it's a statement of the sector, that the different players are trying to secure their space with IP. So maybe collaboration or some other aspect could be considered there. Okay, so these are challenges, and let's move on. So the motivation at the time, and since we're looking back quite a bit a while, for me was to find a methodology, find a way of expressing that where we are and where we should be going, and how to express this, and actually talking to the board of the company. So it needed to be a non-technical way of expressing how we can get to market, and that there are two aspects required. Not just that we are having a product, it also means we have to have a product that is capable of entering the market, because it's expected to be competitive within the market. So this two-dimensional thinking of commercial readiness and economical performance came about. And over the years, we've had quite a few developments in the technology performance level, methodology and the supporting tools being Excel sheets to web-based tools. And so I talked about the beginning already, and maybe some major landmarks on this time scale is that some early versions adapted to the wave energy price were used in the wave energy prices that kicked off in 2014. And I think, positive observation was that it was possible to use this tool to down select out of 92 applicants that were only required to basically, with respect to 15 questions, describe their technology. And using the TPL assessment at the time by a multiple of judges, and each submission judged by at least 3 judges, and with a permutation ensured that we don't have kind of structures of bias in there. So we down selected to 20 technologies, and the positive observation was that when the individual bias of a single assessor, by being maybe more harsh or more easygoing than a different one, was taken out by normalizing their values with their own average, then the ranking of the assessment was very consistent across the different assessors. And that was the important thing. The absolute value wasn't really important. The value itself of a TPL assessment isn't important. Much more, it's only the most condensed summary, and that's a very kind word to use for a number. Important are the answers and the thinking that goes along with reviewing these answers of the individual assessment questions. So, of course, that was one landmark on this timescale. Another one is that we underwent, and I'll go to that in a little while later, a very comprehensive system engineering analysis of the whole wave energy problem statement, and came up with version 4, which was a complete overhaul and a very detailed work. And later on, we changed the representation of the tool from Excel-based to web-based. And we have ongoing efforts of adapting the technology performance level assessment and associated tools to the different powering the blue economy markets, and also to tidal current energy technologies. So that's all I want to say about this timeline. And what we get out of this, so these technology performance levels aim to integrate techno-economic assessment aspects, as well as things that are related to be satisfied for technology to enter the markets, which are environmental, social, and safety aspects. And in a sense, one could say it is a combination out of a TEA analysis and a life cycle assessment analysis. And what comes out of this system engineering analysis and the structuring of this is a hierarchy of criteria and questions that help in the assessment. And the top categories are those that you see in this circle in the middle. So some of them have a lot of detail in lower structural levels, and some of them much less, but they have turned out to be mentioned at this highest level because they have all have a significant importance and a kind of a standing on their own right. Okay, then what comes out of this, and this is actually the definition of the very beginning, is this desire to express the potential of a pre-commercial technology to have to be economically viable once it's fully developed to be a product. So the aim is to say, at, for example, TRL 3, technology readiness level 3, which is maturity of how close am I of having a product, and how far did I travel from having had an idea and the first formulation of the technology concept to that product. That's TRL. So I'll rephrase that sentence, or I start again. So the idea is that at a given TRL, for example, 3, we want to be able to identify the potential of this concept and potentially design to be economically viable once it's fully developed to a product. There's no point saying my TRL3 technology prototype or my TRL6 technology prototype costs that much because it's a prototype. It's a completely different thing. But we want to understand if this concept has potential to be economically viable when fully developed. That's the relevant question, but also it's a very difficult question because yeah, it's not easy to do. It's not an assessment. It's an assessment of what we have at that development stage and the projection of what it could look like when it's fully developed. So it's ambitious, but not to do it is much worse than doing it in an inaccurate way. And so another characteristic of the approach is not to say, okay, I need to add up all the costs, CAPEX, OPEX. I need to make reasonable assumptions about availability, and I work with numbers and quantified aspects only. The idea is to say, and there is, in my view, truly no very different approach to say, I have to look at the drivers of cost and performance at low TRL and identify those and try to identify how they come together to later on at TRL 9 or when fully being developed as a product to forecast, well, no, that's a bit to anticipate what the hard numbers of cost and performance and all the very quantifiable things look like. So the point here is to mention that we are looking at drivers. So that means, say, in an LCOE analysis, the term redundancy isn't a cost item or a performance item. It's a characteristic of a technology. And if we ask ourselves at TRL 3, have my concept and my fundamental approach have redundancy? Then this may be a valid question in order to identify aspects around CAPEX, because I might be doubling up on something, or availability, because my failure rate might be lower / the consequences of a failure might be less. So this is the thinking. So consider cost and performance drivers at the earliest possible stage. And sorry, I should just say, so the lowest row, and I should have said this in the first second when I shared this slide, no need to read that. That is basically just saying we have definitions, rough definitions for all 9 levels, but the main 3 categories of low, medium, high basically say if we think that something is low in TPL, then we anticipate that it will not be economically viable when fully developed. When it's high, we feel that it can be economically viable and competitive in the market as a renewable energy form. And yeah, of course, these are not quantitative statements, because also those formulations could change over time. Competitive can change because energy costs, energy market prices change. But I feel this is the relevant category. And in between, since we're talking about fundamental conceptual aspects of technologies, there may be technologies where there are some fundamental aspects that give promise, but there are some others. So we feel that within the remaining development process, there might need to be some improvements that might be even on a conceptual level. So basically, left means you can't fix it, right means it's looking good, and the middle means you have to fix it. Okay, next one. Now, I want to talk a little bit about this process that I mentioned earlier on, about the system engineering analysis that we did in order to develop the methodology. So that was on the time scale in 2016-17. So what we did is we, clearly formulated the mission statement, which was focused on, and still is focused on, utility grid, wave energy technology markets. And from this mission statement, and the process can be applied to other markets too, which we are doing. From this mission statement, we can identify the context of this market, we can identify the stakeholders and the life cycle stages. And when doing so, one easily identifies a good bunch of life cycle stages and a large number of stakeholders. And what happened then next is to formulate capabilities and impacts that the stakeholders want to see across the life cycle of the technology from the technology. So what does an insurer want to see and need? And at what phase? So when does the insurer need something to happen when we have procurement taking place? Or does the IP holder need something to happen at whatever place, time in the life cycle, and going through all stakeholders and local communities and everything? And the capabilities describe what they want the system to be. They want it to be efficient. They want it to be quiet. They want it to be not visible, stuff like that. And then the functions are focusing on what the system needs to do to have those attributes. And then there's a large iteration machine needs to be applied to this to have a mapping to say, okay, if my system from all these stakeholders needs to be A, B, and C, what kind of functions do I need to have? What does the system need to do to satisfy exactly this capability? And this has been my biggest chessboard that I've been playing with over the years in terms of a large matrix of capabilities and functions across the matrix of stakeholders and life cycles. But what it leads to is to the functional requirements. So this is a more precise formulation of the functions. And when we have these in combination with the capabilities, we have to, we have to check if those actually then satisfy the original mission statement, because it's quite a bit of a process and we don't want to be deviating. And when we have all this done, we can have two offsprings out of that. So the functions, what the system is supposed to be doing, they are close to technological requirements, functional requirements. And these drive innovation. So I can, for example, say, if I want something to be efficient in the sense that it is high conversion efficiency and it's broadbanded and it's very controllable and it has inverse power flow capabilities, then I can start these requirements. I can start with such requirements to start an innovation process. And the one that we've been using in the main project that's running these activities is techniques for inventive problem solving, or as an abbreviation in English, TIPS, or in Russian, that's the origin, TRIZ. On the other hand, closer to our theme here, the capabilities, what's the system supposed to be, and when you then have a description of a given system, you can check if it has these attributes. So that's the basis, the capabilities are the basis for an assessment methodology. And in our case, for TPL assessment. So I hope that this flow of activities has shown that we didn't pull this out of a hat. We have had very reputable and experienced experts involved in this process within the labs and outside of the labs, engaged with stakeholders and continue to do this for the PVE markets. And yeah, so we feel we have something that has some legs to stand on. And the question is now, with having all this done, how do we present this to the users? And at some stage of the tool development, we agreed that we want to formulate the requirements to the users of the assessment methodology as questions, so that it's very concrete, and we give some guidance to what kind of a score for an individual question is appropriate to allocate that score. And for some technologies, some questions may not be relevant or maybe even misleading, so they can be removed for in a particular assessment. Then the questions have a certain weighting that is, of course, associated and is mentioned below with work that is similar to quality, function deployment, and house of quality type work. And also mentioned previously that the structural arrangement of these different criteria have led to a hierarchy. So we have different categories of criteria at different hierarchical levels. That's why in the middle here we are talking about subcategories. Now, these answers to the questions, so I should mention this, it's important that an assessor does not only give scores, but gives justifications for the scores. So the score is more or less a plus up. And an important thing is the feedback that an assessor gives with respect to a question. But we are allocating scores. And then when we have scores given to all these questions, and we know that there's a hierarchy behind them, they need to be combined in some fashion. And that's where we're using different types of means and simple algebra on how to combine them. So it's simple in the sense that it's only algebra, but it's more sophisticated than having purely a linear combination of all criteria, which is often the case in work like, as mentioned below, house of quality and quality function deployment. And why are we using these different kinds of means? For example, when you think about how would I combine the criterion for the large categories availability and power in order to get to something like energy. And if we weight that as a linear function with weights in a kind of the traditional way, and that is often used without, questioning that approach, we would have a situation that is not replicating or representing the nature of how these two properties interact, because they interact in a multiplicative way. So, which means that if I have no availability, I don't have availability 0. And then if I have high power, I don't get an average of half. I just get nothing. So in order to replicate that, we're using these different means rather than purely using averages. Okay, another important design criterion for the TPL assessment is that we, of course, want to be technology agnostic. So, so we're not asking on how far is the free surface in an oscillating water column moving and is there sloshing taking place. This might be a guidance that the assessor can use when looking at a technology, but our assessment has to be independent of it, because it's, of course, it's supposed to be applicable across all archetypes. So it needs to be technology agnostic. The assessment result clearly isn't, but the assessment methodology has to be. Another design aspect is that we made it site agnostic, because it doesn't make sense to say, to do an assessment that is heavily influenced by the selection of the site. So if I have a technology that has good potential, but I pick the wrong site and I make the assessment in a combination, I don't have a technology assessment. I have a project assessment of a technology in a given site. And this may be a very valid task to do, but it's not the one we set out to do when formulating the technology assessment. Yeah. And of course, some questions are difficult to answer when being completely independent of a site. So in some cases, it is appropriate to then say, okay, we're assessing the technology for site conditions that it has been designed for. We've chosen that rather than saying we are using a reference site and exposing all technologies to that, because the diversity of technologies doesn't offer using one or a small number of reference sites. Okay, and here I hand it over to Thomas, and he will talk about the TPL as we've prepared it for you to be used in the prize.
All right, thank you, Joachim. So as Joachim described, a TPL assessment is a holistic measure of a technology's techno-economic performance potential. once it is fully developed for commercial deployment. Our original implementation of this methodology applied to a wave energy farm taken as a whole system. It consisted of 88 questions, and these questions were designed to tease out the eventual promise of the WEC technology and its competitiveness in the energy market. But for the purpose of this prize, we have selected just a dozen questions from the full set, which we thought were relevant to the prize. We simplified them and adapted them to the challenge, which is innovating distributed embedded energy converters. As this slide shows, the TPL assessment shown here in the blue box is one of 4 submittals required in phase 1. We have a template with 12 questions, which is provided on HeroX resources page. And please note that the TPL assessment you submit will not be made public. Also important to note, the scores you input for these questions are not factored in the overall evaluation of your submission for phase 1. So this is intended rather as an exercise to encourage you to think through the strengths and weaknesses of your technologies and consider opportunities for improvement early in the innovation process. We do ask, though, that the strengths and weaknesses identified through the TPL assessment be discussed in the technical narrative, though, which is scored. Next slide, please. Next, okay, thank you. This slide shows the general format of a question in the TPL assessment. This is actually the first question, but the format is the same for all 12 questions. And what you see on the left is what is given, and what you see on the right is what you have to fill in. What is given has 3 parts. The first part is the question itself. The second part is question guidance, which is a more detailed explanation of the question. And the third part is scoring guidance, which gives you guidance on how to go about choosing a score, when to choose high, when to choose medium, and when to choose low. Now, on the right-hand side, what you have to fill in also has 3 parts. The first input is your score. You can choose integers 1 through 9, 1 being the lowest and 9 the highest. The second input field is for you to say how confident you are about the score you input. If there is uncertainty or not much is known, or if the question pertains to what we call a known unknown, then you want to flag it low confidence. But on the other hand, if you have good justification for the score you selected, you can flag it high confidence. The third input field is for you to write down your justification for the score. Here you can explain why you chose the score you chose, cite references you used, like standards or other pertinent literature. Next slide, please. The next 2 slides actually list the 12 questions, and we won't go through all of them, but let's look at a couple of them from each slide. The first question here is, assuming your concept has shown functionality during benchtop testing, what, if any, additional improvements will it need to function in the intended ocean deployment environment? And now in phase 1, you are only required to conceive an individual deck to convert mechanical energy to electrical energy. You are not designing the metamaterial or the entire ocean wave energy converter of which the deck will eventually form a part. Nonetheless, the question invites you to do an appraisal of the anticipated challenges in scaling up the technology to ultimately create an ocean wave energy converter. A very high-level understanding of the challenges and a plan to address them are, at best, all we are looking for. For example, ocean wave effects like forces and motions are cyclical, so decks should not only have safety margins for extreme load and motion conditions, but also adequate fatigue lags. Perhaps you could address failures by building in redundancy or designing components to be easily replaceable, or perhaps fundamental breakthroughs are still required. Whatever the paths forward that you see are, score the question and discuss them in the narrative. The second question is about sourcing. Let's go to the third question. The third question asks, how many conversion steps are there within the deck? How many times is the form of the energy significantly changed? What is the design average combined energy efficiency, energy conversion efficiency? What are the energy densities, power densities, etc.? Now, again, you are in phase one, you are conceiving an individual deck to convert mechanical energy to electrical energy. And this question is asking whether you have to go through many intermediate conversion steps in between. For example, are you converting strain energy to pneumatic pressure or even kinetic energy? Is linear motion converted to rotary motion? Are torque and speed changed via a gearbox? So in general, we expect that more conversion steps often increases capital expenditure because then more components are needed. And more conversion steps also decreases conversion efficiency since there are losses at each conversion step. But this may be an oversimplification, and we recognize that not always this is the case. But use this opportunity to discuss efficiencies, energy densities, etc. of your deck. The remaining questions are about manufacturing, expertise needed from the workforce, failure modes and frequency of failure. Okay, let's move on to the next slide and let's pick a couple of questions there. The first question on this slide, which is actually the seventh question, is, are any material types used rare or located only in particular parts of the world? What material types are vulnerable to price fluctuations? Commonly available materials have multiple sources in many countries, and this yields stable supply lines and prices. However, some materials may only be sourced from one or a few regions, and in such cases, the suppliers wield enormous pricing power. Good examples are rare earth elements. It turns out many advanced technologies also do have components made from rare earth elements, such as magnets and batteries. Now, if a significant portion of your CapEx is from such materials, the cost can be directly impacted by the volatility of the rare material pricing. So this is not ideal. So you want to think about these aspects. Then there are questions about new manufacturing capabilities or workforce expertise, whether components can be recycled, safety philosophy, human health and safety. I want to jump to the last question because the question asks whether the deck can operate without external power input, and I think it's phrased a little incorrectly, and we apologize. What it is really asking is whether the deck will sustain damage if any external power source is abruptly eliminated. And this question is motivated by the fact that the grid and connections to the grid can be subject to rapid events, such as disconnections. And in the event of a sudden disconnection or other unexpected grid behavior, the deck should not react in an adverse way that can cause damage to its components or other subsystems. And this question is to make you think on those lines. I know we haven't gone through all the 12 questions, but they're all fairly self-explanatory when taken together with the question guidance and the scoring guidance. And remember, the emphasis is on a holistic thought process and not on finding solutions to all the challenges that you foresee. So I will pass it on to Bill at this point for the last 2 slides.
Thanks, Thomas. My name is Bill McShane. I am a technology manager in the Water Power Technology Office, and I will briefly touch on competitor support mechanisms available to everyone during this prize. We want to support our competitors, and we want to help our competitors be successful. So we'd love to hear from you what other topics would be helpful, what other live training topics would be helpful from you. We're going to get, I think we're going to have a webinar poll at the end of this, get your feedback. We would love for you all the participants or potential participants to take advantage of the teaming platform that we have available. So ADL Ventures is a teaming service that we have. You can connect with them. They can help you identify potential teaming participants that can help you produce your best proposal possible. You can learn about what's going on, and you get leaderboard points for this. So please check that out. Also, we've got leaderboard points. It's the second to last bullet. Wave Venture and Ramble. They can provide innovation methods and TPL assessment support. So this topic for this webinar was all about TPL assessments, getting an introduction to that, and hopefully you're teasing out some really interesting submissions from you guys. But Wave Ventures and Ramble are two companies, two competitor support mechanisms that are available to you to take advantage of and help you with your TPL assessments. If you have questions, or if you want to understand it or refine your assessments. And I'm actually on the prize page right now, the Hero X page, and you find that under, oh my gosh, I just had it here a second ago. I believe if you go under more and then upcoming webinars and reportings, at the very end of that, it says Power Connector Office Hours. And there you can sign up for Ramble or for Wave Ventures. So maybe just to repeat that a little slower, on the Hero X prize page, the InDEEP prize page, on the far right, there's a drop down for more. Under upcoming webinars and recordings, there is a list of webinars and recordings. I believe this is the last webinar that we're holding. And the last item on that, the last bolded area is Power Connector Office Hours. Sign up for time slots. So there's time slots where you could sign up with Ramble and Wave Venture. You get leaderboard points for that. If you don't see time slots that work for you, please let us know. We'll expand the hours. We'll find a way to get you the hours that you want. Oh, I think Jenny just put something in the chat. Thanks very much. This is also contained in the rules document. So it's Appendix C of the rules document. Talks about all the competitor support, and it also refer you to Table 11 in the rules document for all the leaderboard scoring, and that's where it shows Criterion 2 innovation processes, where you can garner, I think it's up to 4 points for office hours with Wave, Venture, and Ramble. So please take advantage of that, because that'll support you with your submission, support you through this process. We intend to have this support available also in phase 2. You can you can create a relationship with Ramble and Wave Venture. So please check that out. Also, if you could, in the forum, so also on the InDEEP prize page on the Hero X platform, you can put a question in the forum about this, and you will get leaderboard points for that too. So perhaps two birds with one stone. If there's something that's not clear to you about this competitor support or about TPL assessment more generally, you could put into the forum your question. You'll get your leaderboard points, and you'll also get your feedback. So check that out. And maybe the last pitch for this slide is, please, if you haven't read the rules document, take a look at it. It's not that long of a document. It really details the scoring. It details the teaming support, the overall, our philosophy and why we're doing this, right? Our core values for this whole prize. And that you'll see that arc perpetuate into phase 2 and to phase 3 as well. So that, if you're on the Hero X platform, I guess I should tell you exactly where to find it. On the Hero X platform, under resources, I believe it's the second item under resources, is InDEEP official rules documents. So I'll say that slower because I speak a little fast sometimes. But on the Hero X platform for InDEEP, there is the area for resources. If you click resources, the official rules InDEEP officials rules document is the second one. So please, oh, and I think Jenny's putting it there too. So that should answer all your questions. If it doesn't, please put them in the forum. You'll get points for the forum as well. You can also get more questions answered through Yet2. This is kind of nice on the side. Yet2 can help you. Wave Ventures can help you. ADL Ventures can help you. Ramble can help you, and you'll get leader points for interacting with them. So next slide, please. Oh, and I stole the lead from the next one. Please read the rules document. Here it is. You'll get a more in-depth look at the prize overall, what topics, how we're scoring it, where you can get support, our core goals, and it'll give you insight into what we're planning for phase 2 and for phase 3 as well. So please check it out. There's the direct URL. And again, if you're on the Hero X platform, you can find it under resources. Take a look. If there's something not clear, let us know in the forum. We want to answer your questions. We want to enable you guys to have the best proposal and the clearest proposal or application that you can have. So if something's not clear or you have more questions, put it in the form and you will get points. We'll encourage that way by giving you some points for that as well. And we'll refine or revise the official rules as necessary. We try to keep it to a minimum, but if there's something we didn't think of or we learned, we will be open to that. We'll have to work with the broader prize team, but that definitely happens. So please take a look. I believe that's the last screen or the last shot. And then I don't know if Jenny or if you're taking this last, but thanks everyone for your participation. I think we've got 29 participants now. This is great. I don't know if there's going to be a survey, but I'll hand it off to you, Jenny. Thanks everybody.
Awesome. Thanks so much, Bill. We had a couple of questions that came in here, so I just wanted to read these off for the team, and we can just address them for everyone ahead of time. So the first question here that's from Guillermo. Guillermo, please correct me with another chat if this is not exactly what you intended here. But my interpretation of this question is, for any submissions that come in, can they be relevant for any water system besides just the ocean? So could that include deployment in rivers, lakes, or other similar bodies of water?
I guess I could take that. Do you want me to answer that, Jenny?
Yeah, thanks, Bill.
All right, so the prize, if you read the rules, the prize is specific to ocean wave energy. So this prize is quite specific in that regard. If you have technologies or ideas that aren't applicable to wave energy, this prize isn't necessary for you. But there's all of these other opportunities through the Water Power Technology Office. So check out the other things we're doing. And I guess also for that case, you could reach out to ADL Ventures, to Ramble, to Wave Ventures. They maybe give you some ideas as well on how you might be able to make it applicable for this prize. So maybe that's over answering, but this prize is specific to wave energy, but I think there may be lots of opportunities for you, perhaps inside this prize, but certainly in the broader scope of the things the Water Power Technology Office funds. So I'm interested. If you've got ideas, we're quite interested.
And just to add to that, Bill, there is also a couple of tables that are included in the rules document that give you guidance on exactly what are the areas within your technology that they need to operate. So if you take a look at those tables, that'll give you pretty good guidance on what does your technology need to react to. So even if you've never deployed it in the ocean or it isn't currently relevant to the ocean, if it can operate within the ranges that are detailed in those tables, that's a really good starting point for you to reference. All right, then the next question here is more specific to TPL. So the question is the outcome of a TPL a well-presented LCOE?
So I can talk to that. No, it's not, because there's a big distinction between having hard numbers for components and for performance that's based on evidence and the cost and performance drivers. So we are asking, what are the attributes that will be relevant to for cost, performance, reliability, availability, and everything that eventually will go into deciding what an LCOE will be. But we're not claiming that at TRL3 we are trying to identify an LCOE at TPL9 or post market introduction after learning curves. These are different goals. So the TPL is more concerned with saying, hey, there is a driver that is not looking good at conceptual level, and we have to take care of it. The importance of TPL and the criteria that are driving it are more important, are more geared towards identifying strengths and weaknesses and guiding the technology development process. And that's where its strength and focus is. Because at that stage, an LCOE assessment that tries to come up with a hard number, and of course also identifies where are the weaknesses and the strengths, where it, sorry, I lost the train of thought, but I think you still know what the difference is. And maybe a final, an example for what is meant by this. So if you do an LCUE assessment and you have a technology that's maybe at TRL 4 or 5, and you need an availability for this technology. So, but you don't have it. None of the activities that are being conducted up to TRL 5, say, give you an availability. Because an availability of a prototype is irrelevant. Because, for example, at the reduced scale, even of 1 to 4, a full-scale hydraulic system wouldn't be a hydraulic system anymore. Or if it was, it would be an entirely different one. So these TRL activities haven't given you an availability. So you have a choice. You can either say, well, my technology needs to have an availability of 90%, otherwise, we have a problem. So you use 90%. And I'm exaggerating here, but I'm trying to get the colors right of my statement. Or you say, I don't know the availability, but I can think of criteria and characteristics of a technology that will influence it. And then I look at those 15 different aspects and reflect on them and answer questions that are related to them. And then I get a feeling for what my availability might be when this thing is fully developed. So that is the significant difference. And I might be simplifying things here, and I don't, but I'm trying to make the differences clear. And please, Kevin, can you tell me if I answered your question? And if you want, tell me what well represented means.
Joachim, while you're waiting for that chat, I looked in the rules document. LCOE is never mentioned in the rules document. So we mentioned cost over 20 times. There's a lot of reflection on cost, but we do not go after LCOE. And I would also say you can reach out to Ramble and Wave Venture to help you with your cost of informing your TPL assessments with cost stuff with interactions with Wave Ventures and Ramble. So sorry to steal your thunder, Joachim.
No, all good. So Kevin, do you want to ping if I answered your question, or if you have follow-on questions? And if you want, let me know what well presented is. Widely used, maybe. Okay, there's something here. Well, okay. No, I disagree with that statement. TPL uses, as far as possible, quantitative considerations as far as this makes sense and is meaningful. I'm quite strong with this answer because the direct consideration between quantitative and qualitative means qualitative is imprecise and you don't really know, so you remain qualitative, and quantitative is precise. And that is not correct, because when there are questions and considerations where you can make qualitative, meaningful, valuable statements, but you can't make qualitative statements. And when you then make a qualitative statement, you might actually go wrong. So I want to be clear about, because we have an embedded bias that, so the lower level information is the qualitative one and the higher quality information is the quantitative one. And that is not generally the case. I'm trying to be quite strong about this because measurability in general is overrated. And unfortunately, qualitative aspects are often dismissed because they're hard to quantify. And that's where things go wrong. If I do not deal with something that I cannot quantify, that is not a criterion to take out a consideration and a focus point and a potential failure of a technology just because I can't quantify it. So it's dangerous to use the quantifiability of aspects to consider if I use them or not, to consider if I deal with them or not. I'm being quite strong about this because I lived through situations where the non-quantifiability of aspects led to the neglect of them, led to, well, a chain of events which led to an end of a company. So, okay.
Thanks for that, Joachim. And Kevin, if you have any other follow-up questions, please just feel free to reach out to us on the forum directly or on the prize email address, so we can just continue this conversation further. And Paul did have a very specific question related to one of the TPL questions. So Thomas, I think this one is likely for you. Can you further explain question number 10, safety in the context of a distributed system where part of the unit's failure is part of the distributed design philosophy?
Sure, I can take a shot. Hey, Paul, thank you. Thanks for the question and for tuning in. So question 10 asks, has a safety philosophy been incorporated into the design process? So here we mean safety in terms of risk to people, property, and the environment. So, you want to motivate consideration of these aspects early on in the innovation process. We want you to think about whether there are the materials that you're choosing or the operations that are required will potentially pose any safety concerns at any stage of the life cycle. So does that answer your question or clarify it a little bit?
Yes, it does, Thomas. Thank you.
Okay, thanks, Paul.
Yeah, I read it as reliability, so I should not have, but.
Maybe if we don't have another question, I just want to add maybe a sentence, the attributes, and thank you for the response there with the thank you. What the TPL assessment is trying to do is to definitely be holistic. Along goes with this statement, if I can't quantify, well, maybe I can't deal with it and I have to wait until I can quantify it at a later TRL stage. If we go even further, we say TPL, we're aiming for being holistic so that we do uncover unknown unknowns to known unknowns. And we do admit we have to deal with known unknowns, even if we don't know how to deal with them. Maybe we have to develop a tool that we can deal with them. And maybe TPL is one of those tools because it's trying to tell us how relevant that known unknown that we don't know how to deal with it is in the context of the overall capability of the system. Yeah, okay. So holistic is maybe more the difference between the two approaches. And I finally want to say there's no competition between those two approaches. They have different purposes and are more or less relevant at different stages of the development. Okay, thank you.
Great, thanks, Joachim. And thanks so much, Thomas and Bill, for the presentation here as well today. Appreciate everyone taking the time, because I know we're just at about the time period here. So if you have any further questions, as always, please feel free to post them on the forum. We'll discuss them internally as a team and come up with any responses that are necessary if it requires any additional discussion. And please do take advantage of those office hours and sign up for the leaderboard to make sure that you're getting points for your participation today. I saw one person did, but I know that is not all of you. So please do actually click through and take that step. And Kim, I just saw you come on camera if there's anything you'd like to say as well.
Yeah, I just see that Bill has mentioned Rumble a few times. Rumble has 16,000 people, but it's just me who will be on this process, and I would like to help if I can. And yeah, if the office hours don't suit you, you can also write to Jenny, and maybe she can pass it on to me, and we can find a better date. Next week I'm available, so there could be more than just 2 days. That's all.
Great, thanks so much, Kim, and thank you all for taking the time. We'll speak to you soon.